Yeah, so I thought we'll start doing the Patreon video chat. So actually, I mean, we've only got one person on the Hangouts. Just a second. Okay, I don't. So it is working now, but we're. I was getting an echo, so let's cancel that. Right. So first thing I reckon is actually look at how to get a build going. So I'll just swap over to a screen share. Right. Here we go. Okay, so I've set up a virtual box on my system. So this should, once you've got VirtualBox installed, this should work pretty much the same on. Oh, hi Noah.
Oh, hello.
Yeah. So.
Recording?
Huh? Yeah. Sorry. I'll just switch back. Just a sec. Hello.
Hello.
Right. Yeah. So just doing like getting started with the build on VirtualBox. So this is like general VirtualBox window. I've set up a virtual machine just simply with Ubuntu on it and nothing else. It's just a Ubuntu 18.04, so just the standard one. I'll just swap over to the window, which I hope is going to work. Just takes a few seconds to boot up. For some reason, this was miles faster before. Okay, good. So this is literally what you get when you first run it. So the first thing we want to do is, just so that we can get the firmware off it, we need to do this insert guest edition CD thing. It'll say it needs to download it. Say yes. Unfortunately, it's not showing the download window here. But just a second. Okay, good. So hopefully now it's inserted, it'll ask us if we want to run this file. Say yes. And then for some reason, we have to just do one little shell command after this. Just run the terminal. And do sudo usermod, which is going to add some permissions to our user just to let us use this shared directory. My user's GW on this, but you probably use or just use whatever you've got. Okay, and then I'll just restart it, which will hopefully go a lot quicker this time. And that's basically all we need to get started for the compile. If you were on something like Ubuntu for Windows, that wouldn't be an issue. And again, if you're running Linux natively, that's not an issue. But well, if you're on Mac, there are kind of ways to do the build, but sorry. Okay. Yeah. Sorry. So if you're on Mac, there are ways to do the build, but it's just a bit frustrating to get set up. So I won't really cover that here. This is like once you've got the VM, that will work on platform for everyone. So let's give it a sec. Hi, Marcus.
Hi.
So I'm afraid it's basically a blank screen at the moment. We're just waiting for the VM to reboot.
I missed the beginning. Is this, what step is this? Is this a...
Okay, yeah, sorry. So this is just to get a build of Espruino going, like completely from scratch.
Okay.
So, and hopefully we're basically there now. So we just run the terminal. We need a few things to get started, but which we need Git, Python, and curl and make, and that's basically because I installed the absolute minimal version of Ubuntu I could. So yeah, no, you were asking about the about trying to get kind of the SDK 15 and the Bluetooth 5 features. So hopefully, I may not cover exactly that, but I'll kind of show you what you need to do to get it running. Right, so we've got those things, and then we literally just get Espruino. So you do the git clone, hub.com/Espruino/Espruino with a capital E. And so it doesn't take ages. We can just say depth 1, which will get like the very top version of it, which makes things go way faster. Because otherwise you're getting the entire history of every commit that there's ever been. So we can actually compile it just for the system as it is. Whoops. Just by typing make. And right, okay. It's again because I installed the minimal one. Actually, let's forget this one for now, and let's just compile for something like the Pixel. So if I you just type in source scripts provision.sh and the board name that's in here is actually the one from, if you go to espruino.com/JSON, what I should be doing is actually a screen share of the whole screen, but unfortunately my screen's so big that it's kind of painful to include it. So this provision thing basically drags in all the stuff you actually need. So this is dragging in NRF util, which is a Nordic utility that kind of mashes all the various bits of the firmware together and then signs it so you can do an over-the-air update. Okay. Which will be done in a second, I hope. And then it'll actually just grab the GCC compiler that's needed and stick that in as well. Getting that. Yeah, so this is one of the things of running in the VM. It's just that little bit slower than it might be normally. But it should only be a few seconds. Right. Actually, while that's going, I can show you kind of roughly what's inside Espruino itself, how the firmware's put together. Just a second. Okay, so in the Espruino folder itself, actually, it's much easier if I do this from a web browser. Just a second. Okay, so in the Espruino repository, we've got the source folder, which is kind of all the core bits of Espruino, like the interpreter itself, and also a few of the kind of the API functions, sort of built-in functionality like array buffers, date, one wire, stuff like that. Then for every individual type of board, you've got something in targets. So for instance, the Nordic ones are in NRF5X. The other Espruino boards are all STM32 based, so they're in STM32. Then you've got the Linux port and the ESP32 and the ESP8266. So for instance, the NRF5X one's reasonably tidy. You've got main, which is just super simple, actually. Has the main function, which just literally initializes something and then just keeps running through loop. But then you move on to things like JS hardware. That these, it's probably easier if I just show you the header file. So basically, it's got functions for initializing the hardware, resetting the hardware, and then you've got things like these ones, pin set value and pin get value, are like really simple IO functionality. And pretty much once you've got these, and you've got the one that sets pin state, which is basically what would happen if you call pin mode in Espruino. You could do software SPI, software I2C, software serial. Actually, no, you couldn't quite do software serial, but you can get quite a lot of functionality just by implementing them. And then you've got other things like the watching, and then you've got UART, SPI, hardware SPI, hardware I2C, and stuff like that. Right, so now this is, right, for some reason, it still hasn't quite finished doing the this sort of GCC. When I was running through this as a test, it finished it in about 10 seconds, but it's because we're live, I think. So yeah, so in here we've got the hardware, we've got libs, which is probably the more interesting one, which is all the functionality for specific stuff. So we've got Bluetooth LE, we've got all the networking, and then kind of very device specific stuff as well. Like the Pixel obviously is still using an NRF52, but this is code that's just for Pixel.js. So this will, let's have an example. Menu's kind of not a good example, but okay. So so hang on. Yeah, so set contrast. Pixel.setContrast literally just calls into this code. And if you ever want to find out what this code is, some of you know this already, but if you go to the reference and you find something you're interested in, like maybe get battery percentage, you can click this little arrow next to it and it'll go straight to the file and where in the file it is. So in fact, this one's deprecated, but it's calling into the Espruino get battery function that was there before. Right. Just a second, because okay. So it turns out that the VM had finished, but it hadn't updated itself. So let's go back to that.
And this is specific to the Pixel, right? That battery percentage?
So the battery percentage, that function is, but there's now this one called e.get battery percentage, which is supposedly on anything that can connect to a battery, it'll try and tell you what it is. So on all of the NRF52 based ones, it will try and work it out as if it's running off a 3-volt lithium battery. But like in your case, you're going to be running it off a LiPo battery.
Yeah. Yeah, it's always 3.3, right?
Yeah, so unfortunately, because the only way it's working out the battery that's remaining is looking at the actual voltage that's on the chip itself.
Yeah.
And it's going through a 3.3 voltage regulator.
Yeah.
But we found that it's quite good for like the final 10%, because you do notice a voltage drop off below 3.3 as the lithium ion battery runs down.
Okay.
But you can't tell. So you can have a warning, but you can't tell anything about the battery until it's down to the final 10%.
Yeah, well, that's useful because otherwise just kind of random things start happening as the battery runs out.
Yeah. So I mean, so I guess that would be a good one on. I don't know what you. Yeah, you could flash the red LED or something as a warning, couldn't you?
Something because there's a lot of I haven't quite figured out. I might do some tests to see what kind of things will start happening, but so far it just seems kind of random.
No, it's all. I mean, I guess a lot of the other boards it just
shut off.
Yeah, and annoyingly it shuts off when you connect to it to try and see what's happening. So normally it's fine, but when you connect, there's that peak of power draw, the battery voltage drops in it, and it dies.
Right.
Okay, so going back to sort of this thing that I skipped before, you can just like make, and it will build the whole software just for Linux, which is kind of the fastest way to do it, which hopefully will be done quite soon. And then if you're writing just like a simple function that's not dealing with any hardware, you can test stuff out really quickly. So this is now Espruino that's running just within Linux itself, and you can just control C out of it. But if you want to build it for a specific board, so maybe you want to build it for this, I did that provision for Pixel.js, but actually it has exactly the same effect as for Puck.js and the MTBT42. So I can do the command to make it if you say board equals whatever the type of device is, and I'll just, all the devices are listed in the boards directory. See them all here. Yeah, so board equals this. We normally say release equals 1 because now on a lot of the boards, if you compile in all the debug information with all the libraries that are in there, there's not enough room to fit it on the board. And then depending how you want to send this to the board, if you're going to send it through like a development kit, you don't need this. But if you're going to send it using the firmware update, you can do diffuse update build equals 1, make, and why did that happen? Okay, that's particularly frustrating.
Yeah.
Again, I actually ran through this whole thing. Oops, I don't know either. So it's actually in the path. Oh, I know what it is. Sorry. It's because I control C'd out of this and did it again. So the ARM directory was there, but it hadn't finished unpacking it properly. So basically, if you did wait until it was finished, it would work. But anyway, we can actually skip this because we don't have to do it in the VM. Okay. Oh, it's done now. Okay. So if I've actually let it complete this, it'll work. Now I think Yeah, don't want any of that. Let's just quickly see whether okay, so if everything's working, when this is finished, there will be a that's why I missed this step. So you need to go to shared folder settings, and then add a shared folder to basically a blank folder on your computer. You just do auto mount and make permanent. And I should have done this before I rebooted. So one of the things with this is that when we compile for an embedded target, we turn on something called the link time optimization. So that's basically GCC loads absolutely everything at once and then tries to work out what it can inline between files, because normally it doesn't do that. So the idea is it makes the file quite a lot smaller and hopefully makes your application finish faster, but makes it run faster. But it does take a whole bunch of time. So this one's already, it's now created the firmware there. So if I'll restart this now, but I'll go on something else. If all's working well, that would actually give you a firmware file in the shared folder. As it happens, I already have a firmware file in the shared folder, hopefully from what I did before, which is, so if I move over to the web IDE, right. Okay. So there are actually various ways you can actually you can upload the software. If you're running on the machine that you're actually doing stuff on, you can usually say make and then flash after or serial flash after, and it will directly write it onto the device if you've got a debugger connected. But in the flasher,
about that, can you connect a debugger to the mod?
Yes, yeah, yeah, absolutely. So I've got one here. Just a second. I'll just I did have one here. Right, so this is one of the ones I have set up anyway. This is like, I don't know if you've seen these.
Yeah.
These are the RNA52 DKs. You basically, in fact, the newer ones of these have all these named, but you just need to look up in the data sheet and connect SWD, SW clock, ground, and 3.3 volts. And unfortunately, the ground that you have to connect is there. So I have this nasty thing. To connect to the NRF, the MDBT42, I actually had it kicking around here, but I've got a pile of stuff on the desk. Oh, here we go. It's quite nasty, but there are two.
Those tiny pads.
Yeah.
Okay.
Yeah, it's a bit frustrating to get onto. So basically those two.
Okay.
But yeah, so you can do that. It depends how much developing you're thinking of doing with it. What I'd probably say is you can actually build just for this board. So as long as you take off the flashing thing, you can build and flash really, really quickly and easily. And it behaves pretty much identically to the MDBT42. and then when you're ready, you can write it on using the Bluetooth update.
Is button 1 the same as button 1 on?
No, I don't think so.
Okay.
But hopefully you can, like, if you're writing some extension to it, you can write that extension and it will work.
Okay.
Regardless of whether you build it specifically for this board or for the MTBT42. So cool. If I go to here, so I cheated in here because normally there's only a flash from URL. So very soon you will have a flash from file button, and then so like if I have the Wi-Fi one, which I'll just put in because that's the one that I compiled previously, and you can just do the usual stuff, and magically it'll work when it's uploaded. Yeah, so other things about this that are
so this is connected to the debugger. So this takes, how long do you think this takes normally? Like 20 seconds for the debugger
to solder it on
program?
or yeah, I mean, not as long as you've got fine wires, it's not a difficult thing. And actually it's, oops, I forgot to take it out of the bootloader. Anyway, so it's there. But I'll show you this. So yeah, if you don't have these pins on it, then it's actually much easier to get to those, and just poke them in from the side. So when you've got the debugger, what operating system do you usually develop on there?
The Mac OS.
Mac. Okay, so I think that's like once you get set up, you can run. There's a tool called NRF Connect, I think. No, NRF Util that you can install. That's just a Python thing, but it just works really nicely with these. Or in fact, you don't even have to, because you can just copy the file directly to the debugger. So now this is all kind of stuck in there. If I'll just show you what it's like on. I actually do it on my computer. Okay. So like if I want to actually to build for a board like that, I can do v6+1, and then I can just say make flash, and it will build absolutely everything it needs, and then it'll, when it's done and it's linked to everything, it'll automatically send it over and reset the board. And especially if you're just changing one file, you don't have to go through all this hassle. So again, it's doing the linking, which takes a bit of time with this link time optimization. But second. So sometimes it's particularly hard to see why firmware update isn't working. I've had a few when I've been fiddling around with smartwatches and things. You can have managed to set flags on the chip that make it very difficult to do stuff with it. But actually, none of the Espruino boards are like that. You basically just 2 wires if you're powering them from something else even. So the programming is like 15 seconds and that's it. And then hopefully it's available. Yeah. Yeah, it's hard to actually show you. Actually, so I guess a good example then would be, now I'm actually running with this, would be to try and add some function to it. So normally what you do, so this is just really frustrating with the not having the two desktops. Just 1 second. And I'll try and sort this out. Because just trying to flick between windows is a nightmare. Okay. So this is going to be a very, very small screen. I'll just have to make the font really big. Okay. So, and I'll try and do this with a text editor then, because I don't think it's going to work on a Is that going to work? It's probably still not very readable, is it? Okay, now how's that looking on? I can't actually see anything anymore. Nope. Can everyone see everything okay on there? Because currently I'm kind of working blind. I can't see what you're seeing.
No.
Can you see the VM or? Hang on. Right. Okay. Yeah. So it kind of is working. Let's get all this out of the way. So to actually add something to the to this, is the font okay in this? Can you more or less make stuff out? Yeah.
Yeah.
Okay. So normally you could, if you're doing things properly, you'd create a folder in here. You would add two files like that. You don't actually need this update.js file. I think that might be left over from something else. And then you basically want to add these to the make file. So if we look at, actually, I'm lying. What you want to do is in the board file for the specific board that you're targeting. So, for instance, the Pixel.js one. We've got a whole bunch of information about the board. So you're asking about buttons. And for instance, here we've got all the buttons are marked here with exactly which pins they're connected to. So you can change that for a specific board. So if you were making a new board, you could just fiddle with these. Obviously, in the case of the Pixel, it's got the LCD in there as well. But what we've also got here is specific makefile defines. So for instance, this one is saying to compile in support for the WISnet Ethernet networking and to make sure that it's the 5100. So if you then wanted to compile for the 5500, you could just remove that flag. But the JS file, you just need to add, so for the actual file that we're looking at, you just need to add the wrapper sources in here. So the thing to do really is to kind of, it is documented in a file called build process, but the easiest thing is probably to look at what's been done for another board and use that. So if you've done your specific board, let's, have we got, okay, we've got the MGBT42. So let's move to that one and I'll just add something for that. Again, I'll just make a file for this. And we'll go and we'll copy, where were we? Just as a base, I tend to use other files that are there. But there's actually, Jürgen's done like a really good walkthrough of exactly what to put in files from scratch. But I'll just deal with this and this. I'll just get rid of all this stuff. And for now, we'll just leave all this stuff in here. So there are some interesting things in here that I'll leave in so we can see them. Okay. So, hang on, this. I'm aware this is kind of a bit. I should have started with one that's a bit simpler. Okay, so the general format of these files is wait, 1 second again. So we have these specific comments that start with this sort of /JSON, and then there's a little bit of JSON code in here that that is actually documented in scripts as common.py. So there's a bit at the top of here that shows you all the stuff that you can have in here. So the idea is you basically say what kind of thing it is, the class that it belongs to, the name of it, and then under generate, you give the name of the function that implements it. So in this case, it's called this, but let's just add it to the E class for now. Let's create a function XYZ. And let's just make it return a integer as well. So I think in here it was, yeah, you basically say, I'll just leave these blank. We basically make it return an integer, and we'll just make it add 42 to it. Now in this sort of JS far int and int are used interchangeably, it doesn't really matter too much. So we've got these ones which are of this form, and you'll find pretty much all of the Espruino functionality is implemented like this. And it's done so that it can be, all of these can be added to a simple table at compile time and can be really compacted down. These guys are functions that get called when the interpreter first starts up and when it shuts down. And by shuts down, I mean like if you type reset, it will shut it down by running this, and then it will run init again. So if you, for instance, if you're using a variable for something, you need to deal with what happens with that variable and get rid of it. And this is done for reset, it's done for save and other stuff like that as well. Idle is actually called each time around the idle loop. So basically when it's finished processing everything, it'll call that idle function. And then if all of the idle functions return false, it'll go to sleep. Otherwise, it'll just go around the loop again. Okay, so we've got all that. We've added it to our board here. And I think, actually, we just need to add a header file for it, which includes this. So let's literally just whack that in there. And save as.h. Okay. I've lost my the window that I used. Just a second. Right, here we go. So I probably don't even have to make clean for this because I haven't changed any header files. You know, I really do have to make clean. Sorry. So hopefully when this is done, I'll be able to connect to it and there will be a new function in there called e.xyz that we can fiddle with, and hopefully it'll add 42 to every number that goes into it. Just while that's uploading, I'll put this in. If nobody's used the command line app before, it's got this kind of nice shortcut where you can, like, if I list things here, it used to be that you always had to look and then type in the correct number. But here we go, I'll be back now. But you can actually just type -d and then a few characters from the name. So this one will match that. If I typed in pixel, it would match pixel.js. Okay, so now we're connected to this board. And if I look at what's in E, is XYZ there? No, of course it's not. Okay, well that was a bit sad. Let's have a look at what's gone on. Sure should have gone in. Ah, sorry, I didn't save the file. That's a huge mistake, wasn't it? Yeah, cool. Right, so anyway. Okay, fatal error, no such file. And I've probably just saved that in the wrong place, haven't I? Okay, so the other thing I missed out in here then was that you have to add the include directory as well. But it used to be that what you'd do is you'd actually edit the make file for all of this stuff, but it got really, really complicated having loads of if specific board stuff in the make file. So it moved on to doing it in these Python files, which isn't quite as easy as it could be. But yeah, so that's all working. Okay. So the other thing in this that you can do is, am I doing it in? Yeah, so the Pixel uses a library called graphical menu, which you can pull in on any device. But in the Pixel, it's built in. So to actually build it in, literally all you have to do is add this line, and you have to make sure that the sort of the JS file that you want to include is in the libs.js directory. But we actually, if you look in libs.js, actually, there's a whole bunch of stuff. A lot of these are done for the Nordic thingy, but the rack boards use these things as well. So it's kind of handy to be able to just build them in and have them come out of flash memory. It's not actually in storage. It's a slightly separate thing. It's actually stored as a as part of the firmware itself. So, okay, this is done. Let's try connecting. Are we in it? Okay, I've done something horribly wrong then. But if everything was going well, that would work. But I'm aware that I'm just wasting a bunch of your time going through this at the moment. So I can I'll come back with, I'll like email some code in the forum or something, showing you it actually working and doing what it should be doing. But to add C functionality, you basically just need to write a header like this around some stuff. And again, if you find something that works the way you want, you can look it up in the Espruino reference and then click that button to get through to the actual implementation of it. Right. Did anyone have any questions about like stuff around that? I know I'm kind of whoops. Right, that's better. And I'll just try and get my desktop back to some sane size again. Yeah, sorry. So was that helpful at all? Has anyone got any questions around it, or like?
I think for me, I'm not advanced of a user to do that, but I think it was valuable to see what's going on under the hood and how to potentially change stuff if needed.
Okay, cool. So I guess the other, I'll just have a go at screen sharing this thing. Where are we going? Okay, so the thing with the SDK 15, just very quickly, so hopefully at some point it'll actually get built into that provision script, so everything will be done automatically. But currently there's one board that uses SDK 15, which is this NRF 52840, which is kind of a new chip which kind of needs it. So
is that available is that available, that firmware?
So the firmware isn't available as a build, but you can build it.
Okay.
And I could email you a version, like a build of it. That wouldn't be an issue if you wanted to try one out.
Yeah.
So you can run it on, currently you can run it on the 52840 board, the dev kit that looks a lot like that 8321. Or I believe there's a USB key that you can buy, that you can run it on as well.
I have one of those.
So I haven't actually tried that, but I think there's actually a thread on the forum about that. I think there's been some success on that. So basically all you actually need to do is add this line under the makefile thing where we had all the where we were adding that line to add the extra functionality for this NF SDK 15. But then originally when I started off, I started adding all of the hardware APIs for every chip into here. So like F4's got all its library files, and then like they just keep getting worse and worse. So the NRF 52 SDK 12 has just pages and pages of files, and it just really bulks out the repository. So I wasn't going to do that to the SDK 15. So what you have to do is download SDK 15 from Nordic, stick it in this file, stick it in this folder, and then add these patches to it, which if you're on Linux, it's nice and easy. It's a very simple command. Okay, I won't actually paste it up here. I can kind of do that on the forum, or like probably more usefully, I can do like all the ESP8266 and ESP32, the provision script pulls in everything that's needed for them. So that would be the kind of the same thing to do, I think. But once you've done that, you can actually just build for it, and magically you have this board working with currently the 52840. It's got USB support for COM ports, and it's got the Bluetooth advertising seems to work okay. The one thing that is broken I know of is the Bluetooth scan response, and that was just an annoying change in SDK 15. that needed a bit of time to work around, which I haven't had yet. But yeah, I think otherwise that's pretty good. Okay, so just very quickly, the one thing I realized I didn't add was how to add CC2000 support, and literally it's as easy as like if we go into that board file for like this one maybe. So hang on, what was it we had? Okay, so for instance, suppose you wanted to re-add a build for the Espruino board. The easy thing to do would be to go to here, like this one has WSNet equals 1 in here. You could just have put that as CC2000 equals 1, whack it in there, and then you need to delete some things to make room for it. So you probably just get rid of graphics and maybe file system, you didn't want them, and then hopefully the builds would go through and you'd be absolutely fine. Cool. So I suppose final thing to go through quickly would be just now we've been through like the really painful process of doing this. I'll show you, Jürgen's done this really nice firmware build tool, which I don't know, is it easier if you do a demo of it, or shall I?
I would say start with this, and I will give some commands between if I know some.
Okay. So
first of all, I think you would start now.
Actually, where was the link to it?
Take the URL from your invitation.
Oh, from the email.
Easiest one.
Yeah, just a second.
There's the Patreon. Patrons. What?
The what? Sorry.
I can't. Go to the forums, the place for Patreon patrons.
Oh, hang on, I've got it. Sorry. There we go.
Oh yeah, you got it. Okay.
Oh.
So what you see here is a starting point. Okay, let me take over a little bit. Yeah.
Yeah.
Okay, what you see here is a starting point, and you see that once you start the application, the internet, the Espruino board is selected as the first one. So what you see under details, I can't use the multi details. Yes, you see some information which is coming from this PI file that you have just seen, and there was some other informations. So you take the other one. Yes. Okay. Could you please open setting for libs?
Go up to what? Sorry.
No, one under details.
Okay. Yeah.
Second. Okay, this is the predefined parts, the predefined libs, which are used for the ESP32. If you click on a different board.
So, like we were looking at the Pixel.js in here. So a lot of these libraries are listed here, and it's basically those that you get to kind of really nicely click on and off.
So you choose another one. Okay, you see a different one. And the option you have right now is to select or unselect one of these options. Okay, next point in this part is please open the extension from GitHub repository. The idea behind this is that we have some predefined JavaScript commands, which the one that you see here are mainly some of them that I built during a lot of time. And you can see in there, as you have just heard from Gordon, this JSON parts, etc. And the idea is, yeah.
Right, so
you see the
just say these are the JSON things again.
Yeah.
But yep.
Okay, if you click on Schmidt trigger, the last line, this one is added to your firmware. So you have a new command. If you open Schmidt trigger.c, the C file, see there are some commands in. So this is the implementation of a very simple Schmidt trigger. Schmidt trigger is something, it has one input, one output, and two levels inside. If you are above the high level, then it switches the output to true, and it stays true until you are below the low level.
Is this a hardware thing for ESP32 then, or this is it's just an example for kind of a JS library?
This is a general library.
Okay, cool.
If you go back to the firmware, you see two parts here. You see the general part on the left side, and on the right side, you could see special for one family. Go to ESP32 or select the ESP32, yep, and you will see the difference.
Ah, nice. Okay.
Yeah. So, if you want to add some,
oops.
Yep. Okay, go down, please.
Just,
could you please remove this family part? Click.
Oops. Hang on.
It does not remove.
We'll just pretend that didn't happen. And okay, right.
Okay. If you want to add some JavaScript written modules, this is the one coming from Gordon's GitHub board.
So yeah, so these are basically the ones.
Yes.
Sorry, that are in here.
Mm-hmm. Okay, if you click on one of them and select one, and on the right side, this I button, you should get this MD file for that.
Yep.
Yep. And if you click, okay, close it. If you click on the upload button, this is added to your version of firmware.
Nice.
So in this case, it should be possible to delete this, the SIM 900.
Yeah.
Oh, yeah, great. At least one thing is working. So if you want to compile this now, you only have to click on the top. There's a firmware.
I won't go into that. No.
Yeah, this one. And you have to wait some seconds. Since we use the ESP32, it's only the binaries are created. This takes, as you can see, this is a very slow server. And once this is done, it opens the firmware folder, and where you see all. This is download only because you selected the binary.
Mm-hmm.
Yep. If you select, let's go to Makefile shell. Yes, open this one. And
do you want to look inside it?
I don't see anything.
No, just a second.
Ah, yeah. Okay. Here you can see how this was created. So first of all, I changed directory. Next, we have some exports to do. Some exports which are ESP specific, and one which is the path for the compiler. Then I always run automatically a clean. And next, some files are defined. So the gendir, which is the directory where everything is generated, releases is therein, and you see set defines. There is another file in this firmware directory where some definitions are in. So set defines. These are the definitions that are in. Yeah, okay, go back, please. In this case, we did not change any of them in the details part. So this is as usual. If you go to unsupported make, to below here, here you can see another way how to add modules. You can add commands for wrapper sources or commands for JS module sources here. So you don't have to modify the Py file for that. Oh, what else do we have then? Go to wrapper files, please. Yeah, okay. Let's take blacklist. Let's imagine that you would like to do something, to do a firmware for training. And inside a training, you don't want the guys to do some stupid things. And one of the stupid things they should not do is the evil. So you unselect, or what you also can do is, could you please scroll up? Okay, there's a list box on the right.
Yeah, this one?
Yes. Please open this list box. There should be another entry. Saved version. And now click the button on the right of the list box. And you can see there are some already predefined. So if you do this for training, you don't want the guys that do the training to do, for example, peek or poke into the memory. So you switch this command off. And yeah, you could also click on one of the classes.
Yep.
Let's take the E class.
Okay. Where are we? Oh, yeah. Sorry, that one.
Yeah.
Okay, and you can grab the whole class out, or you can.
And you can uncheck all this inside the E classes. This is something for the E class you would not do, but maybe for SPI. Yeah. If you don't use SPI inside your project, why should you have it in firmware?
Yeah. Yeah.
So this is one more option to modify or to customize your version of firmware.
Yeah. Nice.
Logging we have already seen, details we have already seen. Yeah, there's one thing, one more thing is on top of the screen, you see there is a project called My Project. This is a name you can choose by your own. And if you next then click on the green arrow down, wait a second. Oh no, sorry, the other one.
Okay. Oh, brilliant. So you can actually save all that.
Yes. Yes. There are still some things which need to be done.
Sorry, a sec.
Where are you right now? I lost you.
Oh, yeah. It's actually, no. I was just going to look inside that project file. But yeah, it doesn't really matter.
Okay. One last thing is on top of the list of boards, you see this one, the check boxes.
Edge.
And you can compile against the actual release, which should be 202 from today, but I didn't copy this. I have to do this tomorrow. Or you can compile against the edge, where the edge is the most actual part, which is in GitHub, available in GitHub.
So that would be the files that are usually in Binary's Travis Master.
Yes.
But obviously you can then add your own changes on top of all of those.
Yeah.
So yeah, no, that's
okay. I think this is a quick and hopefully understandable explanation what this tool should do.
Brilliant. Thanks.
You could. Oh, wait. One more thing. You could go to logging one more time and open the log directory. And here you have standard out and all the other commands which might be helpful if you're running into an error during compiling.
Yeah, which these are just
when
you're compiling, there are quite a few warnings in here.
Yeah.
The newer versions of GCC tend to, every new version of GCC, they add more warnings for certain things that I don't necessarily get around to.
There are tons of warnings. Yeah.
It's
not that easy to figure out which of them are really helpful.
No, so I do try and go through as time goes on and like squish some of them, but often it's easier to have them in there for a specific file than to turn them off kind of as a blanket thing. Because sometimes when you're debugging, you compile in just one file, that warning will actually be helpful for somewhere that there's an actual bug. But
okay, there's one more thing that I still have to do. These are the buttons on the bottom. Create doku. This is the idea to create documentation for the firmware that you just built. So if you remove the SPI, for example, SPI should not be in documents.
And by documentation, again, that's basically the Espruino/reference thing.
Yeah. It's at least it's the information of this. It's not the same. I want to figure out how to create this in a nicer way. Another thing is this create listing. If you are more familiar with the internals, you might want to take a closer look how this is implemented in assembler, for example. So it's a list file.
Oh, right. Wow.
Some of the boards create a list file directly because this is in the make file. But for the ESP32, creating a listing costs about 1 minute. And so this is removed into this part. Most of the people will not use the list file directly. But if you want to have it, this is the way to create it.
Actually, I'll just very quickly, that reminded me, there is something that might be handy for people who are looking at doing a build. Just a second. So for where there is a list file and you have it, have I got a make listing file here? Hang on.
No, don't see one.
Oh, okay, let's see if I can. Okay. So you could do
command to create it from the ELF file.
You can do a make lst, which will create that file. So in this file, the file itself is pretty huge, with loads of different stuff in it. It's useful if you know what you're looking for. But I've got some scripts in here called find big ROM and find big RAM. So if you run those over the list file, it will try and tell you. Here you go. So all these are more or less sorted by size. There are a few nasty ones in there, but you can see what the biggest variables are in there. So you can see like the variables, which are obviously the actual JavaScript code, the IO buffer, which handles things like set watch, serial data, and then the fat file system. So like most people on the MDBT42 aren't using fat file system at all, but it's still taking up, these values are in hex, so it's about 550 bytes or something. And again, you can do find big ROM. So if you're trying to save a bit of space, you can actually look in here, say certain things in here, like the vector font polys, or like if you JSWrap URL path, for instance, you could go into Jürgen's tool and actually disable URL path, and you could then free yourself up. And that's actually a whole kilobyte of ROM if you need to. So anyway, they're kind of useful side things. If you're like, it's really for if you're delving an awful lot deeper.
Oh, maybe I should add these commands to my tool.
Yeah, I mean, it's I don't know whether, like, at some point, you know, you're going to be better off just developing on a Linux VM or actually on your own PC. I think like the build tool is almost better, like letting people do the basic things really easily, which actually seems really nice at the moment. If that makes sense. But yeah, so I guess Did anyone have any more questions about things to cover, or?
Oh,
No? Yeah.
Yeah, thank you for going over this. I really appreciate it. I was curious about how to use alternative methods for uploading the JavaScript to the device, to the the Nordic device.
Sure. So you've got hang on. Sorry, let's go back to window first. So you've got the this JS module sources thing, which involves building your complete firmware. You've also got if you use the storage library. I don't know if you've come across this. So you can just do storage.write. If you create I don't think it even has to be a .js file here. If you create a file and then require a file with that name, so actually I can give you an example of this. Hopefully, I don't think I'm still connected to this, am I? No. Okay. So if I did .write, then I actually put the contents of that module in here. Okay, so now if I require foo, hopefully it'll give me all the stuff I need. So you can actually, that's now written the code into flash memory that won't be changed even if you change the firmware. So you can fiddle with that in storage. The other thing you can do if you want to is in the where is it? The Espruino command line tool. In fact, the easiest thing to do is to just look for npm Espruino. Then, as part of this, where are we?
Is it using the Nordic serial service?
Yes, yeah. So basically, everything in the left-hand side of the IDE, it's just a standard serial terminal that's going over the Nordic UART service. So actually, if you wanted to upload your own module, all you have to do is connect with the Nordic UART service and send this text followed by a new line, and okay. You're done.
So like even like the Nordic app could do this.
Yeah, absolutely. So there's a web Bluetooth library to handle all of that for you, which is hang on, puckjs.com/puck.des. But you basically you can do puck.write and that handles all Nordic UART stuff. But any library like Node.js library or anything, as you say, like Nordic's already got for handling the Nordic UART service, you can send this over.
Okay.
The only thing to watch out for is that, so generally I send the character code 3 for Control-C and the character code 16. So if you do Control-C and then you do 16, it turns off echo for just that line, which means that, like as it is, as you're typing, all of this stuff is being sent back over Bluetooth. And probably if you're sending a bunch of data, you don't want your device stalling, just relaying that same data back to you. So by sending character code 16, it basically disables it for that line only. So it's hard to, there is a page on this. I think it's interfacing, but I can paste it up on the forum later. So that's
okay. So some of this stuff is on is on your documentation or in the forum or something?
Yeah. I think.
Because I didn't see anything about.
Okay, so we've here's an example with some code for instance, Bluetooth LE code. You've got so obviously it's linked to the web Bluetooth page, but Node.js code which will use the Nordic UART. So you can see here where I'm sending a bunch of code. I'm actually sending this character code 3 to Control C, and then the character code 16.
Okay.
But so there's code for Node, code for Python. So hopefully for kind of, if you just need to make a tool or something quite quickly, it's nice and easy.
Yeah. Okay. Yeah, that looks great. I didn't know about that.
Cool. Right. Just
I mean, my plan is to use. I think I mentioned Cordova, but I think it's going to be similar.
yeah. I mean, if I say I can't promise to learn Cordova, but I can definitely try and help. And I think I'm sure there will be examples of using the Nordic UART for Cordova. And the thing is, that you don't, depending on what you're doing, if you're just trying to upload code to it, you don't need any of the reception stuff. So you literally just need to get this one UART transmit characteristic and write data to it in 20-byte chunks. So hopefully you can ignore a lot, and you can do something quite quickly with Cordova, I would imagine.
Yeah. Okay, great. Yeah, that looks very doable.
Cool. Well, I think that's probably it then. As Josh said, I think that was a kind of a huge information dump, and perhaps not in like the most straightforward way, I'm afraid. But yeah, thanks for listening, everyone, and yeah, and thanks for Patreon as well. It's really appreciated. It does help a lot with kind of all the everyday stuff, trying to maintain and get builds and all the rest of it sorted.
Someone wrote two things in the group chat. Perhaps if you have time, look at it.
Okay, sorry, I've just where are we? I've missed this. I was looking at the YouTube one, and Spence, sorry. Oh, okay, cool. What will happen if I try to compile for the extra timers? So at the moment, none of the utility timers are actually exposed through the firmware. It just uses the one for the for waveforms and digital pulse and all of that, and then all the other ones are ignored. So you can interface them with peek and poke, or things like SPI and I2C. Just tell it in, where are we? Have we got one back here? Just like in here where it's describing the chip, just tell it how many you have, and up to about, I don't know, 6 UARTs and 4 SPI and 4 I2C, it'll just handle it fine on STM32 F1 and F4. So yeah, they'll all magically appear for you. But yeah, cool. I think probably it. So thanks.
All right, thank you.
And right, see you then. Bye.
Bye.